a sea ice summer camp and involves a number of researchers that are involved in sea ice and climate research. So the motivation for this, and I don't have to introduce this topic to those of you on the call, but the motivation for this is really that the sea ice cover is changing in the Arctic. It's changing very dramatically. And while our climate models project that this change will continue into the future, there's a lot of uncertainty in terms of the rate of retreat as projected by climate models. And so there's really a need to do better in terms of predicting the Arctic sea ice into the future. And to do this, to better predict the ice loss and understand its implications as well, really requires the collective insights from different perspectives. So we have a lot of great work being done using observations, both satellite observations, in situ observations, and we also have a lot of great work being done using numerical models to try and understand the changes that we expect for the future. But often there's a little bit of a gap, or maybe sometimes a big gap, between the observational knowledge and the numerical models. So this field campaign was really designed to try and bring these different communities together and learn from each other. So we had this Modeler Observer Sea Ice Summer Camp, and it included 25 participants. They're shown here. This is in front of the BARC Barrow Arctic Research Center on the Narl campus. And this included a mix of modelers, observers, both satellite remote sensing people, and also field people. We had different career levels involved, both early career and later career people, with the intent, that although there's a lot of later career people doing modeling, doing observations, those people are also not very knowledgeable necessarily across those two disciplines. So the campaign, or the camp, included both classroom activities and also on-ice activities. And this project took place in Barrow, Alaska. So we worked out of the Narl campus, which is shown in the upper photograph here. And that provided us with easy access to the sea ice. So we were able to just basically walk out onto the sea ice for most of the measurements that we took. And we also used the classroom facilities shown on the lower right at the BARC Center. So the project took place from May 24th to June 1st, so this was over Memorial Day weekend, and we even had a Memorial Day barbecue to celebrate. But it was, the facilities there were great. They provided us with the ability to really do these classroom activities in a great setting, and then also easy access to the sea ice. So a typical day at the meeting included morning classroom activities, and you can see on the left part of the slide here, there's Walt Meyer lecturing at the top there, and then we'd have very short lectures introducing activities for the classroom sessions, and then we'd have practical sessions, and you can see a photograph of people working on these practical sessions on the lower left. And those practical sessions were really designed to get people's hands dirty, actually doing model experiments, exploring different questions, using different types of models, and also looking directly at remote sensing data. Then we had to refuel, and so we had lunch, and we ate lunch and breakfast generally all together, and that also provided a great opportunity for more informal discussions, getting to know people from different parts of the sea ice community, and also, getting to learn a little bit about people's individual research, et cetera. So that was a really nice kind of community building activity that we had most of our meals together. And then in the afternoons, we went out on the sea ice and we took measurements on the ice, and you can see a couple photographs of that on the right-hand side there. So in terms of the classroom exercises, We broke this up. Most of the classroom exercises focused on model experiments and using models to address a variety of different questions. And then we had one session that was focused on remote sensing of the sea ice. So these modeling sessions used models of various complexity, so allowing the participants really to get a feel for different types of models that are used to investigate the sea ice cover. So this included some experiments with single-column sea ice models, an idealized climate model, which is a simplification of a full sort of general circulation model, but allows you to explore interactions with lower latitudes, and then also some coupled Earth system model experiments where actually the participants looked at simulation output from a CMIP-5 model and explored some questions with that output from a CMIP-5 model. And you can see, the photographs here showing people listening to a brief introductory lecture and then actually getting their hands dirty working on some of these exercises. So the modeling exercises that were a part of these classroom activities were designed to address different aspects of modeling the sea ice cover. So one of these, using the single column model, was designed to assess the sensitivity of sea ice to different parameters. And so this allowed the participants really to get a sense of the uncertainty in the models themselves associated with parameter uncertainty. Then a model of intermediate complexity was used to test hypotheses and basically do some model experiment design kind of work, and I'll actually go through an example of that in the next several slides. And then the final modeling activity was looking at large-scale sea ice loss and the important role that natural variability, internal variability in the climate system plays in terms of prediction uncertainty when you're trying to look at sea ice loss into the future. And so the participants really kind of worked through these different examples and really, actually had to run the models themselves so that they could get a sense of the challenges involved with that, but also the learning process of how models are used to investigate these kinds of questions. So in terms of this hypothesis testing example, so just to give you a little bit more information on what one of these classroom experiments or classroom activities might look like. So Ian Eisenman led this session on using models for hypothesis testing. And the question he wanted the participants to explore was whether Arctic sea ice loss would be reversible. So basically whether or not there was a tipping point in the Arctic sea ice cover. And the motivation for this exercise is that different types of models have shown different behavior in terms of addressing this question. So here on the right-hand side is some example of idealized models. So both energy balance models, an illustration of which is shown on the top. So this is actually showing the temperature on the y-axis as a function of latitude. So these energy balance models allow you to look at things and interactions between the tropics and the poles, for example, but they don't include a seasonal cycle. Single column models, which are shown on the lower right, allow you to look just at the Arctic basin in this case, and this is showing the temperature as a function of time here. But they don't include spatial variation, so they don't include interactions with lower latitudes. And these idealized models, there's been several studies showing that models of this type have irreversible ice loss. They actually have tipping points in the sea ice cover. Whereas comprehensive climate models, and an illustration of that is shown on the left, with full atmospheric models, ocean models, land surface models, sea ice models, these comprehensive climate models suggest that sea ice loss should be reversible, that if we reduce greenhouse gas concentrations, the sea ice should recover. So Ian's experiment that the participants were asked to go through and use a model to explore these questions, used a model that's sort of somewhere in between the full-blown GCM and these more simple models that are on the right. So this model is an idealized climate model. It includes a seasonal cycle, and what's shown is the temperature here from the equator to the pole on the y-axis and over the course of a year on the x-axis. So this model includes both a measure of the seasonal cycle and also spatial variations. And the participants needed to go through a set of exercises where they actually ran this model to look at whether or not sea ice loss was reversible. So they actually had to change parameter values in the model, ramp up CO2, and basically go through these experiments. And what they found was that both the seasonal cycle and spatial variations act to stabilize the sea ice and mean that the sea ice does not experience a tipping point or irreversible sea ice loss. So this is just one example of the kinds of classroom exercises that the participants in this course went through and actually used the models to look at specific questions and give insight on the climate system. So now I'm going to actually hand it over to Don, and he's going to talk about the on-the-ice activities and also some of our future and ongoing work associated with this field campaign.
We spent the mornings in the classrooms and then the afternoons out on the ice. And for the on-ice activities, we broke into 4 groups for 4 activities. Each group had 5 people, 3 modelers, 1 remote sensor, and 1 observer. And each activity had an observer that served as a mentor for that activity. And as always, when we were making these groups, we were trying to maximize the heterogeneity of the group. In terms of these 4 activities, there was one on ice physical properties that entailed taking an ice core, measuring the temperature profile in the ice core, sawing it up into sections, melting it down for a salinity profile, and then taking a look at the crystal structure. There was also an activity looking at surveys of ice thickness, snow depth, and pond depth. In the photograph on the lower left, you see someone using an EM31 electromagnetic induction device to measure ice thickness, but we also just drilled holes in the ice to measure ice thickness that way as well. And you can see from the photograph that we were fortunate to hit the ice conditions that we wanted, which was a transition from snow-covered ice to the beginning of melt ponds. There was also a module on ice morphology, also known as snow machining with friends. The group would go out led by a bear guard and 2 of the observers to look at the ice features within easy distance of Barrow, and they were able to see rubble fields, melt ponds, and we were fortunate in that there was a multi-year flow that was encapsulated in the shore fast ice, so we got to look at multi-year ice as well as first-year ice. And there was also a study of albedo. And to give a feel of what these activities were like, let's take a closer look at the albedo module, spatial surveys of albedo. And what typically would happen is we'd meet at a staging area, walk out on the ice together, carrying our instruments or dragging them in the sled, and then start off with some discussion. In the case of albedo, it was presenting 7 easy steps to excellent albedos to inform people how it's important to know your instrument, know your footprint, measure towards the sun because you're not interested in the albedo of your shadow. Keep the measurement site pristine because you're not interested in the albedo of everybody's footprints. Keep the instrument level. And then that it wasn't enough just to measure the albedo, you had to characterize the sky conditions and characterize the surface conditions. And after that explanation, there was some discussion, some questions, and then we set up a 100-meter long line and measured spectral albedos every 5 meters along that line. And everyone had a chance to do all the different tasks, holding the instrument, running the computer, taking notes. And in addition to the observations, there was some data reduction and analysis. spectral albedos were measured, but then they also, the teams were also asked to convert that to a wavelength integrated albedo. And then the plot in the lower right shows the results of those wavelength integrated albedos for the 4 cases along the 100-meter long line. And never being one to let any data go to waste, we had a nice short 4-day time series that showed some major changes. And there's another feature I want to point out about it. If you look at it, you can see the green curve and the blue curve are pretty much the same, because between the 28th and the 29th of May, not much changed. And if we look at May 31st, you can see that as an evolution of those 2 days where there was more melting and the albedo decreased. If you look at the red curve, it really doesn't make much sense at all. And this was an example that there are some days where you just can't make the measurements you want to make. This particular day, there were high winds, clouds going across the sun, changing the incident levels, and it just wasn't really possible to make good measurements, which is an important lesson for us all to learn. In any good camp, you need to have some sense of mystery. And the mystery that Marika and I introduced was the grand challenge. It was something that we talked about a lot, but never really explained what it was until near the end of the experiment, when one night after dinner, we introduced the grand challenge to the group, which was develop a hypothesis and test it. And you have 48 hours to do it. And you can test this hypothesis using any observations that you had learned how to make, and you could test it using any of the models that we've been working on. I think it's fair to say the next 15 minutes were fairly chaotic as the group of 20, because now it was just one group instead of 4 separate groups, tried to get a handle on this. And then things crystallized when a question was posed, and that's, can we go somewhere else? Or do we have to go to the same place? And we decide, of course you can go somewhere else, because we have synthetic helicopters known as pickup trucks, and we can take you wherever you need to go. And I think that really helped crystallize an idea for the group. And that was a hypothesis that ice conditions will be quite different at a less disturbed site. And this will influence the 2-week predictions of ice melt. Because we had been working at a site right offshore of Narl that had a fair amount of traffic, had dust blown off the road, and was really a disturbed site. For the Grand Challenge Day, the group went up to an undisturbed site further away and then made a set of measurements that showed indeed there was a difference. The ice thickness there was almost a centimeter compared to 85 centimeters at the other site. They made some other observations, came back, synthesized that with some meteorological data, and did 2-week projections that are the results of which are shown in the 2 plots, and showed that it would make a big difference, that a site that was undisturbed, that had dry snow in 2 weeks would have around 12 centimeters of ice loss, compared to the wet, disturbed site where we had done most of the work, which would have had 45 centimeters. It was really, very interesting to see how all this came together. In addition to the morning classroom exercises in the afternoon on ice events, we also had some special events. And the motivation behind this was twofold. One was team building. We brought this group together and we wanted to optimize the opportunity for interactions, to start letting people know one another, build cross collaborations, and just part of that was making everyone feel comfortable. And the other one was to try to work on some broader impacts of this activity. As Marika mentioned earlier, over Memorial Day weekend, we had a barbecue that was really good food and a lot of fun. I think the meals, having all the meals together and having it so that we were making our own meals really proved to be a great way to foster interactions. In addition, we were fortunate that one evening that we had Joe Levitt and Billy Adams come up and spend the evening with us talking about sea ice from the perspective of sea ice services and whaling, and that was just a really interesting evening. We spent a morning visiting the Inupiat Heritage Center, and if you're ever in Barrow, definitely go visit it. It's just an amazing center. And then one evening, Marika and I made a community presentation on sea ice, observing the present and projecting the future. It really had a good turnout. I think there was like 80 to 100 people. There were lots of questions afterwards. Even after we stopped the questions at a half an hour, people still came up afterwards and talked to us. There's just both a lot of interest and a lot of knowledge about sea ice in Barrow. So what's next? During the review process, one of the questions that was raised was, okay, this will be great for the people there, but will it have an impact beyond that? So we've been working to try to create an impact beyond the participants. This presentation is part of that. We also have a fall AGU special session on integrating observations and models to better understand the changing Arctic sea ice cover. We're currently working on a paper on the sea ice summer camp for BAMs. Some collaborations have already started. For example, there's an observer modeler effort to improve the treatment of solar radiation in sea ice and models, basically looking at more wavelength bands. And we've already begun to come up with a journal article that's based in part on the results from the Grand Challenge. So finally, Marika and I would like to say thank you to a lot of different people and things. And the first one is Big Sky, which may be a little bit obscure, but it refers to a symposium that was sponsored by the NSF Arctic System Science in 2003 up in Big Sky, Montana. And it was a synthesis workshop that had a major impact on Marika and me, and in a lot of ways served as guidance for how we arranged the Sea Ice Summer Camp. We'd like to thank everybody that participated. We weren't really sure how people were going to react to this idea, and the response was just overwhelmingly positive. People were great about it. We'd like to thank Joe and Billy for spending a lot of time with us, and the Inupiat Heritage Center for hosting us on a couple of occasions. Fieldwork needs logistical support, and we had great logistical support from UIC and CPS. It's just a very great place to work up in Barrow. We had wonderful support, and we also had the opportunity to interact with bear guards and other people up there that really know a lot about sea ice. We'd like to thank the Office of Naval Research. In 2015, they funded what turned out to be a pilot experiment for this. It was a smaller workshop, fewer people, fewer days, looking at snow on sea ice. And we'd like to thank the National Science Foundation Arctic System Science Program for one, funding this effort, and two, providing a lot of really good advice through the review process. And with that, if there are any questions, Marika and I would be glad to answer them.
Don, Marika, this is Renee. Can you hear me?
Yes.
This is a great presentation. Thank you so much for doing this. Two questions. Number one, are either of you talking with Thomas Young in the PPP about this possibly being a template for a much broader YOP summer school? Because I know there was some discussion about having another educational effort as part of YOP.
So I haven't spoken directly with Thomas about this as a template, but both Don and I have been involved in PPP. I think Don is still on the steering committee for PPP. Yes.
And yeah, I haven't presented this as an idea to the committee yet. But it is something that, Marika and I have talked about, follow-on things. I think the advantage of tying it into YOP is that then it could be expanded to an international level. But that's something that we may look into.
Yeah, I think that would be a really worthwhile endeavor, is to share your presentation and your experience with Thomas and Helge and Kirsten. And then the second question I had was, it was very interesting to listen about all of the questions that you got during your presentation to the community up there in Vero, and I'm wondering if you will be putting together some sort of a synthesis or summary or a listing of all of the questions and answers that were asked of you during that period of time. The National Weather Service, of course, is in the process of trying to establish more of an impact-based decision support services capability through many of the communities, or with many of the communities, and I think the efforts that you have done up there in Vero might serve us very well. And so if you have any sort of written documentation on that community presentation, including any questions and answers that you might have gotten, that would be very much appreciated if you could share that.
Yeah, that's a great idea. I think, as we're putting this DAMS article together, and so we're sort of going through our notes on what things came up as a part of that. And I think it would be really interesting to look back on the questions that were asked. And also, one of the things in this community presentation that came out was it wasn't just questions being asked. It was a lot of the local community giving us their insights on the changes that are happening and the things that they're seeing. So that it was really a very two-way sort of communication. But going through and trying to remember some of those questions and answers, I think that's a really good idea. So.
Yeah, I think that would be really it would be a benefit to a number of parties. Obviously there's a lot of effort on these community-based observation networks and the local and traditional knowledge and sharing of, the observations, not just our physical science observations, but those observations from community whalers and hunters. So I would be very interested in seeing that report.
Mm-hmm. Yeah, thanks.
Marika, Don, it's Martin. I'm sorry I lost my connection at about the time I was supposed to introduce you. This technology stuff here can be so tricky. My question was, did you conduct any sort of formal pre- and post-survey of the campers to assess their expectations and what they learned or what they expected to learn, what they actually did learn, and so on? I think that would be, from an educator's perspective, and to guide any future similar activity, I assume that you might like to repeat this, develop it further. There are others who could learn from it. Did you have any sort of formal pre- and post-survey?
No, we did not. We had a lot of informal pre- and post-survey, but nothing formal. And that would have been something, that's a good lesson for if we do something like this next time. I agree, that would have been really valuable. And perhaps even now going back and getting people's recollections, in a more formal way. We did this, we did get a lot of input from the participants on what went well with the class, what could be improved, et cetera, but nothing as formal as a survey. So that would have been a nice thing to do. And maybe we can do a little bit of that even now.
Yeah,
I'm a little surprised that NSF didn't propose that you do that. But if you are able to capture at least some of the informal information you gained before and after from the campus, I think even that would still be worthwhile, even though it's not a truly formal effort.
Yeah.
Yeah, we did go around, at the last day or two to, talk to people informally, but individually to get, their feedback. But it was positive, but it's all kind of qualitative. I mean, I think that's a good point about doing something a little bit more formal.
Are there any more questions for Marika and Don?
Yeah, I've actually got one. This is Scott Harper at ONR. It sounds like this is really quite a worthwhile activity, and I have no doubt that the CIS experts and observationalists learned a lot from the modelers, and certainly vice versa. But perhaps the most invaluable contribution might be what everybody learns sort of together as a group in terms of where we might need to be going in terms of understanding new processes or what the critical processes are that might not be captured in current models. I think there's some hints in the comments that were made about radiation and the difference between wet snow and dry snow in terms of 2-week sea ice loss and the range of possibilities that are in there. But was there any discussion or will it be part of the BAMS article about kind of what the group thinks the next steps might need to be in terms of improving our understanding of sea ice and its predictability?
Yeah, I think that will be, part of the BAMS article. Some of the recommendations for areas of, future focus.
Okay, thanks. I think that'd be, quite valuable because oftentimes, there's enough process understanding in a particular area. I'm just sort of speaking generally about modeling. But the problem is that, for various reasons, resolution, computing power, the models aren't run at that higher resolution, so you're mostly trying to figure out how to parameterize those processes. There's other cases where the models are simply stuck because there aren't enough observations or not enough understanding of the process themselves. We could resolve it, but we just don't understand enough to actually code it up in the models. And so, sea ice, I think, is a complex mixture of both, where we don't necessarily have the resolution and we don't necessarily have the understanding. So I think sort of a combined approach where you have, sea ice physicists and folks who really understand the observations and the modelers who are trying to do the best job prediction together defining a way forward, I think is, could be quite powerful.
Yeah, agreed. And I think this did help kind of better build and integrate the community that can do that. So I think, there's a lot of collaborative activities, I think, that will be moving forward from the interactions that people had at this workshop. And some of those will be to address exactly what you're saying, Scott, but, very specific topics.
Great. Thanks, Marika.
Marika, Don, Martin again. I recognize many faces in the photograph of the campers. There were a handful of faces I did not recognize. But correct me if I'm wrong, but I would say that in terms of stage of career, age of your campers, you had a fairly equal representation of early, mid, and late career people. And many of the mid and late career people, I would say, certainly would have an appreciation for the observing and modeling challenge of bringing those two communities together and learning from each other. I wondered, would you consider doing a similar camp that's more heavily weighted towards early career sea ice researchers?
Yeah, I mean, I think that's useful. I think a lot of the early career people, while they might fit within one, observer or modeler camp, they I don't know, it seems like a more interdisciplinary, more kind of a group that's already crossing those boundaries a little bit more easily. But And I think sometimes it was getting people like me to go take a measurement, though it's, you know, a little bit different. So, but I think there's value in both, getting, you know, a mix and also doing something more targeted at early career scientists. And I think one of the nice things about this, too, is that, you know, in certain areas, the early career scientists were the experts, and they could really step up and you know, show their expertise because they were an observer teaching a modeler, you know, how to take a measurement. So that was a really nice aspect of this as well.
And in terms of the distribution, it was, you know, roughly a third, early, mid, later on in career. And as Marika said, I mean, one example of that is the ice morphology snow machining trip was jointly led by Chris Polishensky and Andy Mahoney, who are both early-ish stages of their career. And so they were the expert teachers for that segment.
Are there any further questions or comments for Marika and Don? We're already 40 minutes into the meeting. We do have some other topics to discuss, but I do want to take this opportunity to hear more from Marika and Don about this very interesting camp that they did. Or as the second one, really, as Don pointed out, ONR funded what turned out to be a pilot project that informed the second camp just a few months ago. Okay, I hear silence. So with that, I'd like to thank Marika and Don for the presentation. I really appreciate you doing this and telling the Sea Ice team about this camp. I think we've all learned something, and I hope that next time you or somebody else decides to do such a thing again, then you might have a few extra people who are interested in participating and learning from such an experience. So thanks very much.